Okay, so we're looking to see the force of the wind today. We're flying a kite, and there's two different methods we can use for this. So I'm going to use both of those methods and show you the two solutions side by side. Well, one above the other actually. So here's our question, and of course the first thing I'm going to do is to draw a diagram. So here's my diagram. I've got the 24 Newton force here at 64 degrees to the horizontal. The kite has got a mass of 300 grams, so that produces a force with gravity of 0.3 G newtons. And then we've got the force of the wind. I'm putting that here at an angle of theta to the horizontal. So the first method I'm going to use is resolving forces. So let's resolve forces horizontally first. And if we resolve in this direction here, then we've got the component of F in that direction, which is F cos theta. We've got the component of this 24 Newton force in the horizontal direction, which is 24 cos theta. 24 cos 64. So therefore, F cos theta minus 24 cos 64 equals 0. Can't really do much directly with that because we've got one equation and two unknowns. If we resolve vertically though, we've got we've got the component of F in that direction, which is F sine theta, and then we've got the 0.3 G opposite that, so that's why we've got minus 0.3 G there, and the component of this 24 Newton force in that direction, which is 24 sine 64. Okay, so now we've got two equations in two unknowns. Got to find a way of solving them, various different ways. The way that I'm going to use is to use the fact that F sine theta divided by F cos theta is exactly the same, there should be an identity sign really, as tan theta. So tan theta is F sine theta, which is this, divided by F cos theta, which is that, and pop that into the calculator, and we get theta is 66.8 degrees. So therefore the direction of this force F, the wind, is 66.8 degrees above the horizontal. So then what we can do is we can pop that value of theta back into this one, into there, and find that the magnitude of the force is 24 cos 64 divided by cos theta. So that's the magnitude of the force F. What about the second method then? This is the method of using the triangle of forces. So I've drawn here a triangle of forces. And now it is possible, if you draw your diagram on the right hand side slightly differently, if you draw the 24 newtons here and the 0.3 G there, if you've got this force of the wind perhaps in that direction, then it would be possible to construct a triangle of forces which looks like this. The problem with this is that it's not a triangle of forces because the forces do not go round in the same direction. These two are in opposite directions. So that wouldn't be the right triangle of forces to use. The forces have to be going in either a clockwise or an anti-clockwise direction, all joining up together to make a resultant force of 0. So this is the correct triangle of forces. And in order to solve this triangle, we need to know one of the angles. So this angle alpha would be a good one to look at. And what is alpha? Well, if we imagine a horizontal line here, then what we've got is we've got a corresponding angle, or sorry, yeah, alternate angle. So this is 64. So therefore alpha is 64 plus 90. So alpha is 154 degrees. Now we can use the cosine rule on this triangle. And there's the cosine rule, from which we find the magnitude of f is 26.7, which by some luck is the same as what we got before, so that's good. And then to find the magnitude of f, the angle that the force F makes with the horizontal, I need to know this angle here. So let's call that angle beta. And then I can use the sine rule. So sine of alpha over f equals sine of beta over 0.3g. That gives me that the sine of beta is 0.048, and therefore beta is 2.8. So the angle that the force F makes with the horizontal is beta plus 64 degrees. So 64 degrees plus 2.8 is 66.8. So the direction of F is 66.8 degrees above the horizontal, as it was with method 1, thankfully. Okay, so there you are.